This is an airplane. To make it fly, you first design the wings with a special shape. When air flows over them, it splits into two streams, one going over the top and one going underneath. The air on top moves faster than the air below. According to Bernoulli's principle, faster moving air creates lower pressure, so the difference in pressure creates lift under the wings. But this lift alone isn't enough to get a plane off the ground, so you add flaps and slats to the wings. These can extend and retract, increasing the surface area and helping generate more lift. Still, that's just part of the equation. The plane needs power, so you mount 4 jet engines under the wings and add elevators on the tail to control pitch. When the engines start, the plane begins speeding down the runway. You tilt the elevators upward. This causes air to push down on the tail, lifting the nose slightly into the air. At this point, the flaps and slats extend to increase the wing's surface area and catch more air. The increased lift allows the plane to take off. Now the plane climbs, eventually reaching cruising altitude 10,000 meters up. But here's the next challenge. How does a plane turn in mid-air? You could use the vertical rudder on the tail to steer. Turning it would rotate the aircraft's nose left or right, but that kind of turn would be too sharp and uncomfortable for passengers. So instead, you adjust the ailerons on the wings. By changing their angles, you create different amounts of lift on each side. Combined with subtle rudder adjustments, this allows the plane to bank and turn smoothly. When it's time to land, you reduce the engine's thrust. The plane begins to descend. You control the flaps, slats, elevators, and ailerons to manage speed and angle. Finally, you lower the landing gear and gently touch down on the runway. Congratulations, you've just invented the modern passenger aircraft.